Welcome back, Physical Science 20. This is the second section of the heat unit, HT1.2. So in this section we'll look at describe the relationship between thermal energy and temperature, explain what is meant by heat, distinguish between the meaning of thermal conduction, convection, and radiation, distinguish between and give examples of thermal conductors and thermal insulators, describe thermal energy transformation and efficiency. So just like the first part, it's more of a qualitative treatment of heat, nothing to calculate here, simply just going through the notes here, outlining some key points, and then going on from there. Okay, so thermal energy is responsible for an object's warmth or coldness. Just like you highlight that. Thermal energy describes whether something is warm or cold. Thermal energy affects an object's temperature. When an object absorbs thermal energy, its temperature rises. So when you absorb, temperature rises. When you release energy, temperature falls. Again, trying to do away with that conception of if you attract coldness, you get cold. No, it's because you're releasing thermal energy and you perceive that as being colder. This occurs because a large component of the thermal energy of an object is due to the kinetic energy, moving particles. However, the thermal energy of an object also includes stored energy or potential associated with the object's particles. How does the kinetic and potential energy components of thermal energy affect warmth and coldness? Let's take a look. So thermal energy and temperature, since the amount of thermal energy in an object determines the object's temperature, it follows that two identical objects at the same temperature contain the same amount of thermal energy. However, this is only true if they are made up of the same thing and have the same mass. So for example, if I had two iron nails, like you see in this diagram here, and if they're both 1 gram and both have this temperature of 22 degrees C, then we could say that yes, they have the same amount of thermal energy. However, if you look at the next page, if two objects are again the same type of material, but they have different masses, so maybe one's double than the other, so 1 gram versus 2 grams, and they both are at the same temperature of 22 degrees C, they do not have the same amount of thermal energy as seen on the right. The massive nail would have more thermal energy than the less massive one. And of course, this difference in thermal energy occurs because the more massive nail has more vibrating iron atoms. Since both nails are the same temperature, the atoms are vibrating at the same average kinetic energy. Because remember, temperature is a measure of how they're moving. However, the 2 kg nail has twice as many vibrating atoms as the 1 gram nail. So the 2 gram nail has twice as much total kinetic energy. So moving molecules. And if you have more kinetic energy, then you have more thermal energy. Because remember the other day we talked about thermal energy is equal to kinetic energy plus potential. So if one has more kinetic energy due to having twice as many vibrating molecules, the thermal energy is going to be twice as big as much. Two objects have the same mass and the same temperature, but they are made of two different substances, then they will likely contain different amounts of thermal energy as well. So for example, an iron nail that has a mass of 1 gram at 22 degrees C does not have the same amount of thermal energy as an aluminum nail at the same mass and same temperature. This occurs because thermal energy includes kinetic and potential. As kinetic absorbs energy from its surroundings, part of the energy increases the kinetic energy. The increase in kinetic energy in turn increases the temperature. Part of the absorbed energy also increases the potential energy of the substance. Note that an increase in potential energy does not increase the temperature because it's increasing the amount of stored. The proportion of the absorbed energy that goes towards increasing the potential is different. So here is where there's a potential energy difference. If you have different substances absorb energy differently. Maybe I should write a little note about that. Different substances, and we'll see this next with the next section, absorb energy differently. So we could say that is affecting potential energy. Okay, so if you have more kinetic energy, that's going to change thermal energy because more vibrating molecules. Also looking at this, if we have different substances, that's going to affect potential energy because they absorb energy differently. Distinguishing between thermal energy and heat. Thermal energy is the sum of potential and kinetic energies, like I wrote up above there. However, heat is a term used in science to describe the transfer of thermal energy from a warmer object to a colder one. This should be attached. The word heat has many different meanings in the English language and is commonly used to describe a substance that makes objects become warmer. For example, in the phrase, a glass of water has more heat than a glass of cold water, the word heat is being used in a non-scientific way. Because we'll see heat is defined a little bit differently in science. So, the heat responsible for an object's warmth or coldness, it would be more accurate to say a glass of hot water has more energy, thermal energy, not heat, but thermal energy, more kinetic and potential. In most cases in science, it's preferable to use the word heat as a verb, not a noun. So, for example, you might be asked to use a hot plate to heat 250 mils of water to a temperature of 8 degrees. This is the same thing as asking you that you're going to transfer thermal energy over. So heat should be used in terms of transferring thermal energy, not the thermal energy itself. So it's not the heat, it's the thermal energy that's transferring over to from a hotter to a colder one. And that transfer is heat, heating. Transferring the thermal energy over. Okay? Methods of transferring thermal energy. So how can we transfer thermal energy? Since heat is the transfer of thermal energy from a substance with a higher temperature to a substance with a colder one, there must be various methods. In fact, there are several ways to do this. We'll discuss 3 methods: thermal conduction, convection, and radiation. So if we look at conduction first, thermal energy can move from a warmer object to a colder object by a process called thermal conduction. And in thermal conduction, they have to actually physically touch each other. So thermal conduction occurs when the fast-moving particles of a warmer metal collide with the slower-moving particles of the colder material. These collisions cause the slower-moving particles of the colder object to speed up. So you have high-speed molecules hitting lower-speed ones. Some of the thermal energy will be transferred over, speeding up those slower ones, thereby heating up the temperature. And the fast-moving particles of the warmer object slow down. As a result, the warmer object that was originally cools down as the colder object warms up. Its temperature rises. So if you're heating a pot on the stove, so you have your stove top and your pot, they are touching, physically touching each other, so that transfer is happening there. Okay, so hot, the element has more thermal energy than the pot, but as you can see here in the arrows, that energy, the fast-moving particles are hitting the slower-moving particles, thereby giving them more energy and speeding up. You might notice this type of thermal energy transfer if you place a cold metal spoon in a cup of hot coffee. In this case, the fast-moving particles of the hot chocolate collide with the slower-moving particles of the spoon, transferring energy over. The fast-moving particles of the spoon's ladle, the part in the hot chocolate collides with the slower particles, causing the particles in the handle to move faster. This results in thermal energy being transferred from the spoon's ladle to the spoon's handle until the thermal energy is evenly distributed among the spoons. So physical contact, high energy particles hitting lower energy particles, that energy being transferred over, that thermal energy, i.e. the colder material is getting heated up because it's experiencing that transfer of thermal energy. Okay, I think we'll stop the video there, and then in the next one we'll look at the other ways of transferring thermal energy.